Example 4.13 or 5.13 for the given textbooks. For details, please see the description below. In this problem, a long cylinder aluminum rod of 5 cm in diameter are treated from 20 Celsius to an average temperature of 40 Celsius by drawing it at a velocity of 8 meters per minute through an oven. We need to determine the rate of heat transfer to the rod in the oven. Notice that the values of density and Cp are given for the particular material. The first step is to write a balance of energy. We're going to take the system to be the rod, so we have the amount of energy in minus the amount of energy out is equal to the amount of change of energy in the system. The amount of energy in is going to be equal to the heat going into the rod. There is no either heat or work leaving the system, which is the rod, and the change of energy in the system is going to be the change in energy, internal energy, or the change in potential energy, or the change in kinetic energy. The rod moves at a constant speed, therefore there is no change of kinetic energy, and there is no change in position, therefore there is no change in potential energy. Therefore the only change of energy in the system is going to be the change in internal energy. Since aluminum is a metal and a solid, we could reduce the change of internal energy to be simply the value of the mass, Cp, and the difference between the temperatures that we have in the system. In order to solve this equation, we need the value of the mass. The mass is going to be obtained by the relationship of the density, which is equal to the mass divided by the volume. The volume of a rod is treated to be a cylinder, therefore is pi d squared over 4 times the length. And then for this problem, notice that we have 8 meters per minute, therefore we're going to have the time to be 1 minute, and the length for that case is going to be 8 meters. Then we substitute the value of the diameter, 5 centimeters, and the length, and we find that the volume is equal to 0.0157 meter cubed. If we solve this equation for mass, mass is equal to the density times the volume. We find that the value of the mass for this case is equal to 42.41 kilograms. Now we take the value of the mass and we substitute it over here. We go to the back of the book and we find the value for C for aluminum. The value for C is equal to 0.973 kilojoules kilogram Kelvin. And then we find that the amount of heat going in, or the energy going in, is going to be equal to 42.41 kilogram times 0.973 kilojoules per kilogram Kelvin. The change of temperature, it goes from 400 to 20 Celsius. That is the change, and this change is either Kelvin or Celsius, since it's the same value, the delta. So Kelvin and Kelvin changes, kilogram and kilogram changes, cancels, therefore the unit is going to be in joules, which is a value for energy or heat, and this gives us 15,681.23 kilojoules. If we want to find out the heat transfer is simply going to be the change in the heat going in divided by the time, and we took the time to be 1 minute or 60 seconds, so we have 15,681.23 kilojoules divided by 60 seconds, and this gives us 261.35 kilojoules per second, which is the same thing as a kilowatt. An alternative method to find the rate of heat transfer is simply to use the mass flow rate times the value of C and the difference between temperatures. The mass flow rate is going to be found simply by taking the density, the velocity, and the cross-sectional area. The density, we take it to be 2,700 kilograms per meter cubed. The velocity, we have it to be 8 meters per minute, so it's 60 seconds. And the area, we have it to be pi. The diameter, which is equal to 0.05 meters square, divided by 4. Therefore, this mass flow rate is equal to 0.7069 kilograms per second. We substitute these values directly into here. The mass flow rate is 0.7069 kilograms per second. The value of C that we obtained previously, we have it to be 0.973 kilojoules kilograms Kelvin. And the changes of temperature is 400 minus 20. Once again, the change in Kelvin is exactly the same thing as the change in Celsius, so Kelvin and Kelvin cancels, kilogram and kilogram cancels, and notice that we have kilojoules per second, which is the unit of the rate of heat transfer, which is the same thing as a watt, kilowatt. And then we have that the value of Qn, it gives us 261.35 kilojoules per second, which is exactly the same solution obtained in the method done previously.